Welcome to qnawire.
In this problem, we have to find the minimum distance that a woman can turn in order to avoid hitting a seawall. And we're told that we can approximate this problem like a banked curve problem. So if you picture the woman on jet skis as the red dot here, and we draw a free body diagram, we know that our gravitational force right here must be pointing straight down, and our normal force is pointing perpendicular to our surface. When we draw a more detailed diagram of our normal force, we can see that we are going to be splitting it up into two components. A vertical component, which we're going to call Fy, as well as a horizontal component, Fx. Now, since we're moving in a circular motion and Fx is pointing toward the center of that circular motion, Fx must be responsible for our centripetal force, which equals mv squared over r. So in order to solve this problem and find our radius, we're going to have to find f of x. Now to do that, we're going to look at our components. So we can see from the problem that theta must be equal to this angle here as well. And therefore, since this black arrow is our normal force, that fx must be equal to fn sine theta. But we don't know the value of f of n. So we look to our diagram again, and we can see that our y component must be canceling out the force of gravity, and that y component from the more detailed diagram must be equal to fn cosine of theta. So now we have an equation for mg in terms of our knowns. So now we can write that our x component is equal to mg times the tan of theta by the fact that sine theta divided by cos theta is equal to tangent. So we can rewrite this as v squared over r equals g tan of theta after canceling out our m's. We can solve for r, which is v squared over g tan theta. And now all that's left to do is plug in the quantities that we're given. We're told that the woman is traveling at 26 meters per second. We're going to square that quantity, divided by the acceleration of gravity, meters per second squared, and then that multiplied by the tangent of our angle, 22 degrees. And when we solve for that, we get that r is equal to 170.73 meters, which is the final answer to our problem.